Welcome back, everyone! Over the next few videos, I want to talk about how to combine explanation activities and intuition activities. I've done many studies on this question, so it will take me a few videos to get through this. So you may remember from some of my earlier videos that I distinguish two different types of activities that can help students translate between visuals. For example, to translate between ball and stick models and Lewis structures in chemistry. So one type of activities are explanation activities. These activities ask students to explain what information is shown by two visuals. For example, the ball and stick model uses black spheres to show carbon, whereas the Lewis structure uses the letter C to show carbon. So both visuals show which atoms participate in bonding in this molecule. But the Lewis structure makes it easier to see how many electrons participate in the bonds, but the ball and stick model makes the geometrical arrangement easier to see. The second type of activity are intuition activities. Chemists are so fluent in translating between visuals like these ball and stick models and Lewis structures that they can just immediately see that these two visuals show the same molecule. And to get to this point, to have these perceptual intuitions that are almost automatic, intuition activities expose students to many example visuals that are designed so that they draw students' attention to relevant features like the color of the spheres. So I wanted to know whether students actually show higher learning gains of domain knowledge if they receive explanation activities and intuition activities. My first experiment on this was actually on fractions learning. So I worked with elementary school students, and some of them worked with regular activities that did not involve any translation between visuals like pie charts and number lines. A second group received explanation activities. A third group received intuition activities, and then a fourth group received both explanation activities and intuition activities. And here's what I found. Explanation activities alone were no more effective than regular activities. Intuition activities alone were even less effective than regular activities. But when both were provided together, explanation activities and intuition activities, then we saw a significant advantage over regular activities. And I've since repeated this experiment several times in chemistry, and I always found a similar effect. So, I'm not surprised that students who received both explanation activities and intuition activities did so well, because that's entirely what I would expect, because both explaining and intuitions and translating between visuals is really important for learning of domain knowledge. But I had expected that explanation activities alone would also help students beyond the regular activities, but that turned out not to be true. And also, why did intuition activities alone hurt students' learning compared to the regular activities? That was a complete puzzle to me. Since then, I've been able to uncover some of this puzzle, and I want to tell you more about that in the next video.